Welcome to the demo on the lab where we synthesize tert butyl chloride from tert butanol. This is an SN1 reaction. An SN1 reaction is where we have the slow step happening, where it's a unimolecular step where there is only one molecule involved. In this case, that one molecule is the substrate, tert butanol itself. In the slow step, the leaving group on tert butanol will leave and we will form the tert butyl cation, which will then be attacked by our weak nucleophile. In this case, it will be the chloride anion, and we will synthesize tert butyl chloride. So SN1 stands for substitution nucleophilic unimolecular. Now, just like our SN2 reaction where we had the OH group, in this reaction as well, we have the OH group on tert butanol. In the case of SN2 reaction, we had just butanol. Well, OH group is not a good leaving group, so it needs to be protonated and turn it into water, and that serves as the good leaving group. We'll be using concentrated hydrochloric acid, which completely deprotonates in the solution to give us the protons and the chloride ions. And the protons will be picked up by the OH group on tert butanol, protonating it, producing OH2, which serves as a good leaving group. In the slow rate determining step, OH2 will leave, leaving behind tert butyl cation. Tert butyl cation is a tertiary cation, hence it's stable, and it will serve as an intermediate, which will then be attacked by our weak nucleophile chloride ions, resulting in the product tert butyl chloride. Once we have synthesized tert butyl chloride, we will isolate it, purify it, and then test for its purity using NMR spectroscopy. We will also, I expect you to give me the reaction mechanism for this reaction, showing all the arrows correctly, and also to give me the percent yield for tert butyl chloride, knowing how much tert butanol as well as hydrochloric acid you began with, and which of those two should be the limiting reactor.